Wow. Hello guys, hello everybody, hello world, hello Philippines, hello other parts of the world. Okay, I'll be discussing now enthalpy change or heat change through phases and enthalpy change through temperature changes or temperature gradient. Okay, now we need to give you an information that this topic is all about heat is equals to, oh my gosh, mass, mass, mass and specific capacity than the change in temperature. Okay, so this involves temperature gradient, and the other one also is the involving the latent heat of fusion and the latent heat of vaporization. Okay, so like that. So I'm gonna show you a graph, or no, I need to plot the the temperature and the heat, right? Tama ba? Yes, yes. Temperature and heat. Okay. Because in the steam table, you're gonna plot the temperature versus the volume or specific volume and the pressure versus a specific volume like that. But in here, we need to graph the temperature and the heat. Okay? My gosh. Let's review what is enthalpy. Enthalpy is the total heat content of the system. Okay? It could either be transferred from the higher environment, higher cold environment, higher temperature to lower temperature, meaning to say hot environment to cold environment. What I said a while ago, higher cold environment. No, it's not. Higher temperature or hot environment to cold environment or lower temperature. Ganun siya. Okay? So I need to draw an illustration first. Oh my gosh. Sorry. Oh my gosh. Hello guys. Okay, no. So but before that, we need to solve problem also after this. Okay. So but before that pala, we need to write first the values for the specific heat capacity. Okay. Specific heat capacity of water at 100 degrees Celsius is 4,186, okay, joules per kilogram degree Celsius. Okay, and also 1 calorie, okay, from degree Celsius. The specific heat of water. Okay, memorize this one class. Okay, and then the specific heat capacity of ice. So this is a fusion, or melting point or freezing point at 0 degrees Celsius. So we have 2,000, half of it, okay, estimation, 2,100 joules kilogram degree Celsius. You can convert the calorie per gram degree Celsius if you have time, because I don't memorize the value for that. Then convert, no problem. For the conversion factor, then you can convert. Okay? And the specific heat capacity of the steam is equal to 2,000, more or less closer, 2,010 joules kilogram degree Celsius. Okay, like that. So we have now the specific heat capacities. Okay? So meaning this to say the three phases, the solid, okay, the liquid, okay, the ice, the water, and the steam. The steam is the vapor, right? Or exists as a gas, something like that. Okay. Now we need to show now here. For example, this is our chararate. This is our temperature. and this is our heat. Okay, like this. And this is our 0 degrees Celsius. Okay, and this is like this. Okay, like this, for example, only. Okay, like this. Temperature T and the x-axis is heat. Now you need to establish a graph. Okay. Now at fusion, so change from solid state ice to the liquids. It's here. So you will going to hit that one, right, in order to become liquid. Or else you will wait that to become liquid. Okay. But we need to apply heat so that it will become a liquid. Let's say 50 degrees Celsius. Ganon. At 50 degrees Celsius, ice, ganon, okay? Okay, then this is our, like this, and this like this. Okay, so it's here, 0.1, okay? At 0.1, at 50 degrees Celsius, you hit your, this is the ice, right? Or the melting point. Melting point is just nearly the same with freezing point, that's 0 degrees Celsius or 32 degrees Fahrenheit or 450 Kelvin. Okay? So here is the fusion. Latent of fusion in 0.1. Okay, like that. And then we need to graph another temperature. Here, ganon. Okay. And then it will reach to like this. See, 100 degrees Celsius. And here, somewhere here. Okay. Like this. The graph. The next one is 0.1. The next is the 0.2 here. Guys, from 1 to 2, you need to use the latent heat of fusion. That is delta H or Q is equals to mass times the latent heat of fusion. Sa ganitong latent heat of fusion value, okay, we have 3.33 times 10 to the 5 joules per kilogram. And then it is also 79.7 calories per gram. It's up to you whether you use the calorie based or the joules based. Okay, it depends on the problem you are solving. Okay? So, let's write that on a piece of paper and memorize. Okay. So 3.33 times 10 to the 5 joules per kilogram degree Celsius. Another one is we have 79.7 okay calories per gram. Okay, like this. So these are the values to be used here. So, right? Okay, from point 1 to point 2, this is a horizontal. So you will use the latent heat of fusion. Okay, like that. Meaning there's no change because it's still the same. The temperature has no effect because it's horizontal, right? So if the temperature has no effect, it's horizontal. Okay, so that means you will use a latent heat of fusion. Now from 2 to 3, guys, okay, from 2 to 3 here, okay, like that. So this is liquid, okay. You still it at 100 degrees Celsius, that's still liquid. And then after that, it will turn to vapor in 0.4 gas here. Okay, like that. So in here, this is still liquid to liquid, right? You need to use the temperature difference. You will use Q is equals to MC delta T. Okay, from 0.2 to 3 MC delta T. Okay, so your temperature will be 100, final temperature at 0.3, this one, 100, and then 50 initial temperature, 100 minus 50. You will use the QMC delta T. Okay, now at the 3 and 4, you will use the delta H. Q is equal to mass times the latent heat of vaporization na siya. Okay, here in 3 and 4. Straight line lang siya. So straight lines at 3 and 4, the temperature has no effect. There's a change in temperature. So use the latent heat of vaporization from liquid to gas. Okay? So latent heat of vaporization value, there's so many. You could choose either 2,260 kilojoules per kilogram. Okay? You can have also 530 calories per gram. Okay? Something like that. And you can use the other formula. If you convert that to joules, you can still use also, you convert that to joules, you can also use joules. You can use kilojoules and calorie. Okay? So if you have the calorie per gram, which is 530, convert that to joules, right? You can get. And we have also kilojoules, okay? 2,260, something like that. Okay? I think it's gonna be 2.260 times 10 to the 5. I'm not really sure. Better convert that by your own, but we will use either calorie or joules. It depends on the problem of unit and you have to convert that one. There's no issue. Okay, so that heat of vaporization equals to 2,260 kilojoules per kilogram. So that heat of vaporization equals to 2,260 kilojoules per kilogram or 530 calorie per kilogram. Gram, sorry. If calorie ang pares niya gram, joules ang pares niya kilogram. Something like that. Or if you convert that to joules, it can also be whatever unit you will be able to do, as long as it will be cancelled for along during something like that. And then, after 100 degrees Celsius, you still heat that vapor liquid, and then you will now have superheated. Okay, from 4 to 5, let's example here, above. And the temperature will be 400 degrees Celsius, like this. So, at 0.5 plus, is a superheated vapor na talaga siya. Okay? Get the point? Okay. Now we need to have a problem solving now. Okay. So based on my research, okay, this one, I use this problem. This is Chemical Engineering Board Exam 1995. Oh my gosh. So how much energy is required to heat a 7.5 kilogram of ice from negative 30 degrees Celsius to steam at 200 degrees Celsius? It looks like very easy to solve, but actually it undergoes so many processes here. Okay, and then most of the students, okay, will substitute directly the 7.5 kilograms as a mass, and then the final temperature is 200, and then you just choose. No, it's not, because it starts from ice. Okay, so it's fusion, and then change in temperature, and then vaporization, change in temperature, and then like this, blah, blah, blah. And let's graph this one, okay? Okay, let's graph now. Or masabta na ito siya. Where's that? Okay. So this is task key. Okay. How much energy is required to heat a 7.5 kilogram of ice from negative 30 degrees Celsius to steam at 200 degrees Celsius? Okay. Oh my gosh, this is Chemical Engineering Board Exam 1995. 1995. Kasi may mga 1995 na chemical engineering chart. Okay. So let's plot and illustrate to understand really. Okay. Do not use directly the mCdT, ha? Okay. Because you want to be very quick. You will substitute directly. No, it's not. Okay. So we have the temperature at the y-axis like this. We have also the heat at the y-axis. Okay. Since it is negative 30 degrees Celsius plus, it's below the zero. Okay. It's just as shown. Let's put an imaginary line here. Like this. It's gonna be a zero. We should adjust. Okay, like this. So let's say this is 0 degrees Celsius here. Let's adjust the temperature because to make for further adjustment. Okay, and negative 30 degrees Celsius is below, somewhere here. Okay, ganon. Negative, somewhere here. Negative. So start from negative 30 degrees Celsius. So it's more colder, right? Negative, it's very cold. It's less than the temperature of the freezing point of ice. Oh my gosh. Like this. So this is your this is your initial temperature and final temperature like this. Okay. And this is the ice here, somewhere like this. And this is the Q here. So like this. Somewhere like this. Okay. Now you have the point here, like this. Point 1 here and point 2 here. Okay, like that. Okay, so the first thing to do is to identify what changes involved there. Okay, first we need to have the phase change. Q is equal to the mass. We have the mass here, right? Mass times latent diffusion. Okay? So mass 7.5 kilogram. Okay. So 7.5 kilogram. Latent diffusion, which is equal to 79.7 calorie per gram or 3.30 times 10 to the 5 joules per kilogram. So cancelled, right? Okay na siya. So, but I love calorie. Okay, calorie na lang ko yun. Okay, so 1 kilogram is equal to 1,000 gram. Okay, and then 79.7 calorie per gram. Because I don't want to use the exponent. Okay, 3.33 times 10 to the 5 joules per kilogram. I don't want to use that one because it adds the burden during the decimal places, and it's very easy to multiply it with 7 later on, right? So 7.5. Okay. Okay. 0.5. 0.5. Okay. 7.5 times 1,000 times 79.7. So that is 597 change from solid to liquid at fusion process or melting point. Okay, using the latent diffusion. So this is our, let's say, our Q1. Okay. Now, before going to 200 degrees Celsius class, it will still reach to 100 degrees Celsius. Okay, it will not go directly to 200 degrees Celsius because this is really water. Okay, 200 degrees Celsius is here. Okay, imaginary line, diba? Ganon. So this is water at 100 degrees Celsius. So in point, this will become a liquid already, right? So it will rise somewhere here, okay? So, and then our heat also will be here. Connect one here, connect. This will be 3. So at temperature 100 degrees Celsius, make an imaginary vertical horizontal, connect that one. That's about point 3. From point 2 to point 3, this is now a temperature change. Okay, from 0 to, well, from 0 to 100 degrees Celsius. Okay, something like that. So from 0 to 100 degrees Celsius, so our final temperature is 100, and our initial temperature is 0 degrees Celsius. So use Q is equal to mCdT. Okay, at Q2. We should remember, class, that we can apply only the latent heat of vaporization, latent heat of fusion, latent condensation if the graph will become straight. Meaning there's no changes in temperature in the graph. Okay. But if it will become vertical and slant like this, so use the temperature changes from final to initial. Use the Q is equal to mCdT. Okay. In Q2, this is mass. Okay. Mass times specific heat of unsaman, liquid or ice. In Q2. Think. Liquid or ice, it was heated from negative 30 degrees Celsius to 0, it will become a liquid. Okay, from point 2 to point 3, what you will use in the specific capacity? The ice or the water? Okay, it should be the water. Okay, because specific capacity of water is not the same. Remember that one. So when it reached 2.2, guys, it's now liquid naman siya. It's not an ice already. So you should not use the specific heat of ice. Got my point? You should use the specific heat capacity of water. So mass again, which is 7.5 kilogram. Specific heat capacity of water, 4,086. Oh my gosh. Joules per calorie lang tayo. Calorie man ako ang pikas. So we should consistent in our unit, we will use calorie. Okay? So 7.5 kilogram, 1 kilogram, 1,000 gram. Guys, very easy to use the calorie specific capacity of water. 1 naman siya. 1 calorie. Okay? 1,000 gram. 1 calorie per gram degree Celsius siya. So, cancel, grams. Okay. And then times the temperature, class, it should be the 100 degrees Celsius minus 0. Final 100 and 0. The reach saturation temperature. Okay. So, ganon. So this is gonna be 100 minus 0. So it's still 100 degrees Celsius. Okay. Cancel. So our unit now is calorie. So do the basic mathematics. Okay. So 7.5 times 4, 186 times 1,000 times 100. Oh my gosh. Okay. 1 kilogram, 1,000. Okay. Wala lang for 186. Because 486 is, ano man siya, joules per kilogram siya. We are using the 1 calorie per gram degree Celsius para dali. Okay. I don't want to use exponential talaga. Okay? 7.5 times 1,000. If you want to use also, no problem. Okay? It depends on your convenience. Okay, 750,000 calorie. Okay. And now, at point 4, it will become a vapor. So project another imaginary line for your point 4. So this is now, at point 4, this is now liquid turns to vapor at point 4. Now from 3 to 5 of vaporization. That is Q3 na siya. Okay? This is Q2. So latent heat of vaporization. Okay? The latent heat of vaporization is Q is equal to mass. That's the latent heat of vaporization. Mass is 7.5. Latent heat of vaporization is 530 calorie per gram. Because we're using calorie man. Okay? 7.5 times 1,000 times 1 calorie. Okay? Mass 7.5. Latent heat of vaporization is 530. Okay? Ganon. This is convert times 1,000. Okay? So 1,000. So 7.5. 7.5. 7.5 times 1,000 times 530 is equal to 3,000,000. 3,175,000. Okay, this is calorie. It's our Q3. Okay, now our Q4. Okay, our Q4. Q4 is our Q4 class is here. Okay, degrees Celsius now. The last, say somewhere here, 200 degrees Celsius. So this is now a change. 200 degrees Celsius, okay? From 4 to 5. So this is now 4 to 5. Okay? So Q4 is equal to mCdT na siya. Okay? mCdT or delta T. So in here, a specific heat of water, which is from liquid to vapor. Okay? How much? Vapor naman siya sa 4, right? Vapor, pagulong sa 5, steam na siya. So, vapor to steam, we will not use the liquid anymore, sorry. We will use the specific capacity of the steam. Okay, analyze the graph. From 3 to 4, it starts from liquid. Okay. And then 4 is already a vapor. It will hit that 200 degrees Celsius. When it will become a vapor or steam, it's no longer a liquid. So we will use a specific capacity of the steam. Okay, so 7.5. Specific capacity of the steam, as I discussed a while ago, right? Steam, okay, is 2,010. 2,010 joules per kilogram degree Celsius. How can we convert that to calorie? Because we are using calorie now to make it consistent. Wow. Okay, convert na to sa okay, 2,010 joules per kilogram degree Celsius, then 4.184 joules is equal to 1 calorie. 1 kilogram, 1,000. Right? 1 kilogram, 1,000 grams. Okay? It's gonna be, okay. So, 4.184. It's gonna be less than 1 because the specific heat capacity of water is less than 1, so it's gonna be lesser because this is half. 2010. Okay, this is half of 4,186 joules per kilogram. So it's understood to be half for that. Okay, so but let's just with the exact. Okay, so 2,000. Okay, 4.184 times 1,000. 4184. So, okay, 2010 divided by 4184. So it's 0.48. Nearly half, di ba? Sakto po. So 4.48 calorie per gram degree Celsius. There's a change in temperature from ano na siya? 200 minus 100. Okay? Sa Q4. Q4, actually Q4 to 5, Q3 to Q4, Q2 to Q3, and Q1 to Q2. It's gonna be like that, okay? Doesn't matter. Okay, so 7.5 times 0.48, right? Okay. Times 1,000 pa siya. Okay. Sabi mo siyang calorie, right? Okay. So 100 times 1,000 times 0.48 times 7.5, right? 1,000 times 7.48 times 7.5 times 100 times 100 pa. Okay? So, aguroy. Again, 100 times 1,000. Uy, kulang na siya. Okay. Times 0.48 times 7.5. 360,000 calorie. 360,000 calorie. Okay? Review. 200 minus 100 times 0.48 times 1,000. Okay, so that it will not become wrong. 100. Okay, times 1,000 times 0.48 times 7.5. 360,000 lang. Okay, Q4 na siya. Okay. Take note, class. We review from points 1, point 2, point 3, point 4, point 5. So actually, point 1, point 2, point 3, point 4, point 5. But we have now 1, 2, 3, 4 is the other one. So there's a missing point. Let's review. Again, I did not solve this, that's why. I did not solve this ahead of time just now, that's why. Okay, so let's review again. Not perfect. Okay, let's review. So point 1, point 2, point 3, point 4, point 5. It's gonna be, okay. Here at negative 30 degrees Celsius to 0 degrees Celsius, we will use the 30. As we can see here, we still not use yet the 30 degrees Celsius. So we use Q exclude mCdT. Okay, this is from 1 to 2, point 1 to 2. Okay, so like that. Okay, so Q1, Q2, Q3, Q4. So this is Q1. Q1 is equals to mass of the ice 7.5 times, okay, specific capacity of ice, kailangan siya 2,100. Oh, convert na po, 2,100. Okay, 2,100 times divided by 4,184. 0.50. So 0.50 specific capacity of ice. Ice pa man siya from 0, right? Heat mo to negative 30 degrees Celsius. Okay, from negative 30, that's 0. Okay, so that is 150. And then the temperature will be Final. So 0 minus negative 30. It's here in the first part because I go directly to the latent of solution. Q is equals to solution. Actually, they're still here first. Okay, here. Because I come to think there are 1, 2, 3, 4, 5. So our Q also is 5 based on the analysis. Okay, that I reviewed quickly. Okay, it's gonna be like that. Okay, of course you have to review, right? Okay, so this is heat value niya. Okay, here. So 7.5. Okay. Actually, this is very tasky because there are 5 processes to be done. Oh my gosh, what's happening in chemical engineering board exam 1995? Oh my gosh. So this came out of siya. So 7.5 times 0.50. We have heard of choices, ha? Here. A, B, C, D in the problem. We still don't know because I didn't solve just now. Okay, 7.5. More close is our answer, right? 7.5 times 0.5. Okay, times 30, right? And then times 1,000 pa siya. Okay, 7.5 times 0.5 times siya, calorie. So we have 112,500. Okay. Okay. So we adjust this one as Q0. Right? It makes sense. Q0, Q0, Q1, Q2, Q3, Q4. And the Q4 is Q4 to 5. Usarap siya. Okay? Q0 meaning at 0 degrees Celsius sa ice. Diba? Logic. It's okay, right? To put some Q0. It's okay also 1. But it would be perfect to put Q0 because the temperature is 0 on the ice. So Q0, Q1, Q2, Q3, Q4, Q5. So there are 5 heat to compute. Okay? So we now need to add this one. Q total, how much energy is required? Q total, imagine class. The question in the board examination, chemical engineering ng 1985, it states how much energy lang yun siya. So very confusing because it's not stating how much is the total energy required. So of course the student will be confused with this question for sure, 101%. Because it would be better also if you put like this, how much the total energy is required to convert so that the students can understand that it's gonna be having 4 processes or 5 processes in which there are a lot of heat. So this will be confused also because how much energy, because you can use only one formula. You know, the English grammar of the question, something wrong also. But never mind, this energy meaning total energy. What I mean, you will be confused because of the terminology or the grammar in the sentence. Supposedly, if I will be the one who make this question, I will say, how much total energy is required to convert 3 kilograms of ice from 0 degrees Celsius to water? Because class, we have 4 processes, so total. When we are computing the total, and then the question is only like this, how much energy? So it could be interpreted as only one heat will be computed by most of the students, which is Q is equals to mCdT alone. And they will use the temperature 30 degrees Celsius. What's that? They will use the temperature 200 degrees Celsius as their final, and they will use the initial temperature negative 30 degrees Celsius because it was also mentioned 0 degrees Celsius on ice, and then it was also mentioned 100. So this is in this part in the analysis that the 0 degrees Celsius and 100 degrees Celsius will come out. Analysis na siya. Okay? Because in the problem, it doesn't mention there. So normally it will trick the students, trick the RICT for this question. Okay? Even if I will take this, maybe I will use also Q is equal to mCdT directly, and I will use also the specific heat of the steam. The steam is mentioned here. Okay? Or I will use the ice on the water alone. In this case, how much energy is required to heat 75 kilograms of ice from negative 30 degrees Celsius to steam? Because I have an idea that ice is also a steam, and both of them are water. So I have an idea that it has the same specific capacity. But actually, it don't have specific design. The specific capacity of ice is not the same as the specific capacity of the water, liquid, and also the steam. So, but both are water. Okay, only phases are different. Oh my gosh, this is a very good question, right? It leads us to think. Okay, so QT is equal to Q0 at the tahak, fairness. So calorie, so 112, 500 calorie. Plus, this is the Q at 0 during heating from negative 30 degrees to 0. Okay? So this is like this. Okay, Q1 to Q2 is just Q1, right? So we have 527, 750 calorie. Okay? Q3, Q2 is just equals to Q2, right? So Q2 is 750,000 calorie. 750,000 calorie. 3 million. Okay, 1,000. And then calorie. And then Q4, 360,000. Wait, 1, 2, 3, 4, 5. 5 hits. Okay, Q0, Q1, Q2, Q3, Q4. Or we can also have the Q1, Q2, Q3, Q4, Q5. It depends on your arrangement. You can start with Q0 method. Okay? Ano mo siya? 112, 500 plus 597, 750. Okay? Yes. Plus 750,000. Oh my gosh. Yes. Plus 3,375. Ito taas at 00. Okay. Plus 360,000. So we have 5,705,250. Here the choices. 5 million. Oh my gosh! A, 328,855 calorie. B, 107. So there's no such 5,705,250 calorie. So we will convert this to joules because there's measures of joules in CNT. Check. It's 1 calorie is equal to 4.24, right? This is calories. So calorie, 1 calorie, okay. And it's 1 calorie, 1 calorie. So times the siya, 4.184 joules. Nabay joules please the choices. Ay wala siya. Nabay none of the above. So take note, in the examination, there's a none of the above. You will have to answer that because I don't see the answer is in the A to E. And all you have to do that is the case that it's too far. Okay? Like that. So the most closest here is very far really. Okay? So let's review. At Q0, it is a temperature change. So 7.5 times the specific heat of the ice, right? So specific heat of the ice is 2010. You convert that to siya. 2010 H 4.84 joules, 1 calorie. Cancel, cancel. Okay, like that. And then 1 kilogram is equals to 1,000. Okay, so like this. So do 4.184 times 1,000. Okay, 4.184 so 2,010. This is 200 divided by 4.184. This is ice 200 divided by 4.184. So our specific capacity rate sa ice is 0.5 in calorie per gram. Then 7.5 is kilogram. There's a 1,000 here, guys, because this is kilogram of 7.5. Okay? Like that. Okay, so 0 minus 30 is a final 0. Hit mo siya function negative 30. 0 minus 30. So 30. Okay, so 30 times 0.5 specific capacity times 1,000. Okay, times 7.5. So really perfect ang atong Q0, 112,500 calories. Okay? Now we go to the Q1 to Q2. No. We go now to Q2 to Q3, something like that. Okay? The latent hypofusion. Okay? Which is the one. Okay? So, latent diffusion, mass times right? Ganon. Kung hindi mo siyang kikinig, so, ganon. So, mass, 7.5, convert 1,000, 7.7 calorie per gram, okay. Kasi 7, okay. So, 7.5, reviewing, 7.5 times 1,000, okay. Times 79.7 equal to 550 sa Q1. Now, sa Q2 to Q3, change na siya. And then delta T, so ang Q1 na liquid to, ano na siya, liquid to liquid pa siya. So, liquid to liquid, heat from 100. This is 750,000.5. Okay, ang L mula 7.5 kilogram, 1 kilogram, 1,000 gram. Okay, 530 times 7.5. This is 3,175,000 really calorie. And then our Q4 now change from 200, yes, here. No, from 200, so it's gonna be 200 minus 100 again, times the specific capacity of the here is specific capacity of the vapor. Okay? The vapor lang siya. Pagpunta sa for expression siya, di ba? Okay, so convert that one. It's gonna be 4.184. Review. 4.184 times 8.48. 148 kilogram, 1,000 grams. So it's gonna be cancel, cancel. Okay? Like that. Ihimo mo na itong calorie per gram ng 2,100. Okay? So it's less than 1 sa water. Okay? Cancel, cancel. Cancel, cancel. Chum, chum, chum. Kilogram, 1 kilogram, 1,000. So it's gonna be 0.48. Cancel mo siya. So 0.48 specific capacity. Okay? Times 1,000. Is equals to 360,000 calories. So 360,000. So correct. So perfect. Okay. So Q0, correct na siya. 112,500 plus 597, 750. Okay, guys. Okay, plus 750,000. Okay. Taas ko siya, 3 million. No, 3 million. That's also one of the vaporization. Calorie per gram siya. Times 7.5. Yes, 3 million talaga siya. Okay, 3,075,000. Okay, plus 360,000. Ganon. Okay. Okay, plus 750,000. Ganon. Okay. plus 112, 500, okay? Okay. Plus 597, 750. It's gonna be really 5,705,000 calories. Here, convert this to joules. So, calorie, 1 calorie, that's 4.184. Like this. Okay. So, the answer will be none of the above. Letter E, because I reviewed this two times, none of the above. Okay? Charot. Letter E. It's possible also, guys, none of the above, because during the board examination, I also answered none of the above. Okay? Okay, guys, the none of the above will only be just like that if after 2 or 3 times you solve again the problem and the choices is not there. Okay? Before you choose the none of the above, do not rely on one time only. Maybe you are a mistake only and it's there, the answer, okay? Maybe you will just convert that, then it's there. Because sometimes your answer will be there and still to be converted, okay? And you will be deceived that your answer already, but it's not, it's to be converted. But in here, really, 2 times review, it's not here, so it's gonna be none of the above. Okay. Really? None of the above? I want you to later. Okay. That's the like that. Okay? That's very clear. Guys, if it involves a heat fishing, I hope you like this. Let Fisha, yes, let me 54 minutes. You can subscribe to my YT channel if you want, and you can also click the notification bell for some reasons. The voice of my everybody. Okay. Ganun. Char. Grabe! Bakit na the above? Oo nga eh. Klaro dyan. None of the above.